equals 6. Okay, negative 2 minus 4 is negative 6. Okay, so negative 2 minus 4 is negative 6, and negative 6 equals 6. Okay, you might think, oh, wait, it doesn't look the same. Well, what is the absolute value of negative 6? The absolute value of negative 6 is positive 6. And those are equal. So negative 2 does make the statement true. Okay? Both of these values of x make this equation balance or make it truthful. Okay? You put 10 in there, 10 minus 4 is 6. Absolute value of 6 is 6. It works. Drop negative 2 in there. Negative 2 minus 4 is negative 6. The absolute value of negative 6 is positive 6, and it makes the statement work as well. So both of these are valid. Um, are there any questions so far about anything I did there? Please ask me if you're unsure. Anything? Anything? Okay. Let's just do this problem another way. Okay. Let's do it another way. Rather than do it algebraically, okay, rather than do it algebraically, we're actually going to look at it graphically. So let's look at it graphically now. Let me just go to Desmos. Okay. Okay, let's go to Desmos and take a look. So this is much faster than what I did, but remember, you want to know how to do things algebraically too. So the question was x minus 4 and then equals 6. So I have the absolute value. You should write y equals. Y equals the absolute value of x minus 4. That's the left side of the equation. And the right side is y equals 6. Right? Those are the two equations. And I'm looking for the values of x that make the statement true. So I can click here, and I can see that I don't care about the y value. That's irrelevant. I care about only finding x. So negative 2 is an x value, a solution, and 10 is the other solution. So I solved it in 2 seconds, right? I just graphed it, boom. Negative 2 is 1x, positive 10 is the other. I'm done. That's it. Those are the answers that I had. I had negative 2 and 10. So I got the same answers doing it using the graphing calculator that I got, doing it algebraically. And that should be the case. Okay, that should always be the case. Okay, I'm going to go back to the notebook now. And what I'll do is, okay, underneath this, I'm just going to draw what we saw in Desmos there really quick so that it's in my notebook. So it was like this, right? I had the absolute value. The absolute value was something like this. Right, there's the absolute value. And then the line was like this. So this coordinate was negative 2, comma 6. And this coordinate right here was 10, comma 6. So I have negative 2 and I have 10. Those are my answers, so it works, okay? That's all for this one. If there aren't any questions, I'm going to move on to question B, okay? Now, actually, question B is actually much easier than question A. If you take a look at question B, you shouldn't even do it. Why should you not even do question B? I'm suggesting that you shouldn't even do the problem at all. Why should you just leave it alone? What do you notice about the way it's set up? I just need you to look at it, and you could probably tell me why. Yes.
Is it because
C is a negative, right?
Say again.
C is a negative, right?
Yes, 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 yes. Yeah, both of you right. I think two goes to the same thing because C is a negative. Because C is less than 0, it's impossible. It's impossible for this to ever be negative 5. That can't happen. It won't work. Okay. So this one is not going to have a solution. There's going to be no solution. Now, uh, listen. When you're taking the test, you would just write down no solution and you move on. You're done. but only for instructional purposes, right? I'm going to show you what happens if you actually solve this. Okay. Yes, it is a waste of time. I get it. It's a waste of your time to solve it, but I'm going to do it anyway. The reason I'm going to do it is because I know there are going to be students who you're taking an exam, right? You get a bunch of questions. This comes up, and you're just, you're a little nervous, and you don't remember that you shouldn't do the problem because there's a negative there, and you go ahead and work it out. So I want you to see what happens if you go ahead and work it out, because I know people are going to forget not to do the example when there's a negative there. All right. That's going to happen to some people. So if those people work it out, what they're going to get is they're going to get 3x plus 1 equals -5. That's their original, right? And then their alternative is 3x plus 1. Change the sign on the other side, the c value becomes +5. Because a negative is a positive. Okay, so that's what's going to happen to some students. They're going to do this. Then they're going to say, okay, let me solve. They're going to do -1, -1. These are going to cancel. And then they're going to get -6. Then they're going to say, okay, I have to solve for x. So I know that to solve for x, I have to divide by 3. They divide by 3. And then they say, okay, x is going to be -2. All right, they're going to do that. Then over here, they're going to do a similar thing. They're going to say, you know what? Oh, you know what? I'm not going to bother with this one because it's just extra work. So they get x is -2. And now when you try to check this, you try to check -2 and look at what happens. You're putting -2 back in the original, all the way back up in the original. So that you have 3, you replace your x with -2 because you think that's the answer, and that's okay. 3, -2 plus 1, close up is supposed to equal -5. I'm not going to bother doing the other side because it is a waste of time. I want to give you time to practice, but I'm just showing you why this will fail. So now you get here. Okay, you get here. You're going to multiply 3 and -2, and you're going to get -6. Okay, so you get 3 times -2 is -6. Carry the +1, bring this down. Then you might go, oh, look, -6 plus 1 is -5. Oh, it looks like it works. But it doesn't, because the absolute value of -5 has to be taken into account, and that's +5. And +5 is not the same as -5. So this does not work. -2 does not make the statement true. It doesn't work. Okay? It doesn't work. So I promise you, if you solve this one will not work either. It's going to fail. Okay? So it won't work. Okay? So what happens is, if you can remember not to do this example, you'll save yourself the time. If you don't remember, you're going to work it all out. And when you try to check it, you'll see it fails anyway. So you'll see that, okay, the answers I get don't work, and therefore there's no solution. Okay? Now, this is all algebraic, which I know some people don't like. So what I strongly recommend you do before you start doing algebra, before you start doing any of the algebra, I would put these in the computer first and see how it looks before I do anything. Right? It's always nice to have the answers before you start doing the algebra. It just makes it easier for you. So if you try to put in this into the computer, I'm going to show you what happens. Oh, question? Any questions? Anything?
You sure about this thing? Because you can't see.
Okay.
There's some beautiful in my life, and plus superpowers.
Anything?
The game is vehicle.
Let me just to kill the noise. Okay, so no question there. So let's look at this in the computer. All right, 3x plus 1 and then -5. So let's take a look. Let's go to Desmos and put it into the computer. 3x plus 1 is supposed to be -5. So I'm going to go to Desmos. Desmos is extremely helpful for these activities. So it should be loaded into Desmos. It's loading into Desmos. Give me a second. Okay, there it is. It loaded. Okay, so let's take a look at the 3x plus 5 it is, right? So let me go back, erase this. 3x plus 5. And then the other value was -5. -5. Okay, so here's the absolute value, and there's the other function, -5. What do you notice about those two things? Are they ever going to intersect? Is there ever going to be an intersection point?
No.
No. So that means that there's no solution. Since these two graphs never intersect, there is no solution, because the solution occurs where the two graphs intersect, and these don't intersect. Therefore, no intersection, no solution. Okay, so you can always do it graphically first, and you'll see that, okay, there's no solution. There's no point in doing any algebra here. I'm wasting my time. Okay, so that's another way of doing it. Let me go back to Notebook. I just want you to see how it looked. Okay, I'm going to go back to Notebook now, and in my notes, I'll just draw what I see, and what I see is I see this. I see a coordinate plane, right? I see a absolute value equation, and then I see a line segment which does not intersect. Okay, so that's basically what I see. There's no intersection. The other one had intersection. This one has none. Okay, so I hope we're good with A and B, because I'm gonna let you work out 1, 2, and 3, and I'll give you a couple of minutes. Let me just spread these out, so let me go over them. It's a little easier for me. So let me give me 1 second. View full. Okay, so let's put 1. 1 is super easy, and so is 3. So x equals 10 for 2. X minus 1 equals 4. And for 3, 3 plus x equals -3. I'll give you a couple of minutes, all right, to solve these. It should not take long, actually. It's pretty quick. So let's take like 4 minutes, 3 or 4 minutes. It's actually really quick. 3 minutes is even good. If you have any questions, well, I'm listening in. So you have 3 minutes. You go ahead and solve those, then we'll go over them. And 3 is actually the easiest one up here. While you guys do that, let me do the attendance really quick. People.
I'm done.
You got them all already? That's quick. All right, we're gonna go over them in one. Give me 1 minute. We'll go over them. It's almost time. I know they were fast.
I got 2.
You got the second one done? That was the one that involved like thought. Okay. So I guess if people are finishing already, we'll oh, there's still like 57 seconds left. All right, you know what? So if people have it already, I guess we'll take a look. Let me just give it 15 more seconds. All right. So who wants to give me the first one?
I got 10, like -10.
Yes, I agree. 10 and -10, right? That makes sense to me. That's like the first example I did. if you made two statements, x equals 10, x equals negative 10, if you check that, the absolute value of 10 is 10, and the absolute value of negative 10 is also 10. So yes, these are correct. The people who graphed it, if you did it differently by doing it that way, you would see this. Sorry for my sloppy graph, but you would see this. This coordinate here would be negative 10, comma 10, and this coordinate here would be positive 10, comma 10. And all we care about are the x values. So negative 10 and positive 10 with the graphing utility. So thank you, this is correct. This one's done. Okay. Anybody want to give two? Was the only two I had the most work in it. Anybody want to give two a go?
I got 5 and negative 3.
Okay. I agree with that. How'd you do that though? I agree with that.
So I did x minus 1 equals 4, and I did plus 1 to get rid of negative 1 on both sides, and then I got x equals 5. And for the other one,
Nice.
I did x minus 1 equals negative 4. I did the plus 1 to get rid of the 1, and I got x is equal to negative 3.
Nice. Okay. This is correct. Okay. And what we can do to make sure he did it right is I'll quickly just check these by substituting them back into the original. Okay. So if I substitute it back into the original, I'm going to have 5 minus 1 equals 4. And 5 minus 1 is 4. And of course, the absolute value of 4 is 4. Here, I'll check negative 3. I'm putting negative 3 in there. And negative 3 minus 1 is negative 4. So you might think, oh, wait, it doesn't look the same. Well, actually, it is because the absolute value of negative 4 is positive 4. And that makes the statement true as well. So his answers of 5 and negative 3 are both valid answers. If you didn't want to do it this way, if you didn't do it algebraically, and this is right, he did all the work, this is full credit response. If you did it graphically, you would have seen something like this. I'm sorry, my diagrams are not drawn to scale. This is just off the top of my head. Okay, you'll see something like this. And then this coordinate right here is going to be negative 3, comma 4. But you only care about the x, so negative 3. And this coordinate right here is going to be 5, comma 4. And again, you only care about the x, so that's that 5 right there. So this is a graphical solution. You could do this with Desmos, and you can find the x's in 2 seconds, okay? Just using the computer. But I want you guys to do the algebra because I know on the state exam, they're going to say only an algebraic solution will be accepted. So again, I would still do it graphically first, write the answers down, and then do the work. These ones are easy enough where you could get away with it, but you'll see when we get to the harder ones what I'm talking about. All right, really quick, number 3. What should we do for that? This is actually the easiest one up here. Anybody? What does somebody think I should do for 3?
Nothing.
Nothing. Yeah, why am I doing nothing?
Because negative 3.
Yeah, there's no way to get this one. There's no solutions to this because you're dealing with a negative on the other side, okay? Negative 3. So you can't get a negative coming out of an absolute value. That can't happen. It's got to be 0 or bigger. So doing this example is kind of a waste of your time. All right. If you graph it and you didn't do this, that's okay. You should always be graphing it first. If you graph it, you'll see that this one looks like something like this. Off the top of my head here, I could be a little off. Here's my absolute value. Okay, and then negative 3 would be like down here somewhere. Okay, so you can see then that this, and this, they never intersect. There are no solutions. There's no point where the two graphs touch. Okay, so since that happens, there's clearly no solution. All right, I'm just going to start the next item. I'm not going to get to finish because of time constraints, but I started at my other class and I want to be in the same place. So I'm going to start the next one. The next one's a little harder. It's a little more complex, and you'll see what I mean. Here it is. solving an absolute value equation. So now we're getting closer. This is still not a test question yet. It's still a little too easy, but we're building there. Now, you might look at this and say, oh, wait a minute, you know what? I'm not going to do this one because I see the other side is a negative. Unfortunately, you can't do that. You can't just do that because you can only make that claim when the absolute value is alone by itself on one side of the equation. Again, you can only make a claim like that when the absolute value is alone on one side of the equation. Currently, the absolute value is not alone. It's not. Can somebody tell me what's preventing the absolute value from being alone on one side of the equation?
-10.
Negative 10. How do I get rid of that, Sarah? How do I get rid of negative 10?
So add 10 to each side.
This sounds good to me. We're going to add 10 to each side. Okay, we got to get the absolute value by itself to do a problem like this. So now I have 3x plus 9. Notice I still have my absolute value. I haven't not removed it yet. I can't remove it yet. These 10s cancel. And -4 plus 10, that's going to be positive 6. So now this looks like the questions on the last slide. Now it looks like it. I have 3x plus 9 absolute equals 6. The absolute value is now all alone by itself on the left-hand side of the equation. So now and only now can you make your two statements. Somebody want to give me the two statements that we can make?
3x plus 9 equal -6.
Okay, that's the alternative. 3x plus 9 equals -6. I agree
And
with him. That's the right side. Yes,
3x plus 9 equals 6.
correct. Okay. So the original, you just remove the absolute value symbol. 3x plus 9 is 6. And the other one, you change the sign on the other side. You make it negative. This is perfect. Let's solve these real quick, and we'll check this next week when I see you. Okay. So how do I solve this?
Subtract 9 from each side.
And that cancels this out. And then 3x is going to equal -3.
Yeah.
And then we're going to divide, right?
Yeah, divide by 3.
And we're going to have x is -1. Nice. Okay, really quick, we'll take care of this side. -9.
Yeah.
And these cancel, and then 3x is equal to -15, right?
Yeah.
Right, and -9, -6 is -15, and yeah, take it away.
Divide by 3 now.
And we're going to get
-5.
Okay, so because time has run out, we're going to check these on Monday. We're going to go all the way back to the original to see if they make the statement true. I believe they will, but we'll take a look at that again on Monday. So I hate to leave you with this cliffhanger here, but that can't be helped because it's 11:30, right? We started at 10:45. Yeah. So yes, so we'll stop here. There will not be homework on this because we just started, okay? If I post a homework assignment, it'll probably be due on Wednesday of next week, okay? Because I'm not going to finish this probably till I have at least Monday, and then maybe it might even run into Tuesday a little bit. So the earliest the homework will be due is Tuesday night. That'll be the earliest, okay? All right. The other assignment is due tonight. That's the other stuff with the translations. So try to get that into me. I noticed a lot of people have been handing them in.